Welcome to the Explainer. Today we're diving into something called ReAct. It's a really powerful pattern for building AI you can actually, trust. And let's be clear, this isn't about some brand new model or a super complex framework. ReAct is more of a fundamental shift in how we make AI safe enough to use in the real world.
You know the feeling, right? You ask a large language model a question, and what you get back is this beautifully written, incredibly confident-sounding answer. But then comes the big question. How do you know it's actually right? I mean, really, how can you be sure? And that right there, that's the single biggest hurdle to using AI for anything that actually matters.
All right, so let's get into it. To really get why ReAct is such a game changer, we first have to talk about why the standard ways of doing things, well, why they fail. It turns out that just, asking a model for an answer and hoping for the best is a total recipe for disaster when the stakes are high. Okay, so problem number one, and this is the big one you've probably heard of, hallucination. See, a pure LLM isn't connected to reality. It doesn't have a live, verifiable source of truth. It's basically just a super sophisticated predictive text machine. And what that means is that it can, and it often does, just invent facts, figures, even sources, with this incredible conviction. And the worst part? You have absolutely no way to trace where any of it came from. So to try and fix this, developers came up with this clever idea called chain of thought. The idea was to make the model think out loud, write out its reasoning step by step. But here's the catch. What happens if its very first assumption is wrong? Well, that single mistake just tumbles down the entire chain of logic. It's like a domino effect, and you end up with a final conclusion that's built on a faulty foundation, completely disconnected from reality. Then there's the other approach. Just give the AI tools, hook it up to a calculator or a search engine. But the problem is, without any reasoning to guide it, the system is just acting blindly. It's like giving someone a hammer without telling them what a nail is. It might call the wrong tool or use the right tool in completely the wrong way because there's no real plan or strategy guiding its actions. So if none of those standard methods are reliable enough, then what is the answer? Well, it turns out the solution comes from looking at the best problem solver out there. Us, the human brain. The whole core idea behind the ReAct pattern is that it tries to mimic how we, as people, actually think and solve problems.
Just think about it for a second. When you're faced with a really tough problem, you don't just lock yourself in a room and think for an hour until the perfect answer magically appears, right? No way. You think for a bit, you come up with an idea, and then you go check something. You Google a fact, you ask a friend, you run a quick test. You see what happens, you take that new information, adjust your thinking, and then you try something else. It's a constant loop of thinking and doing.
And that right there brings us to the nuts and bolts of the ReAct pattern. It basically takes that really intuitive human process of thinking and acting in a loop, and it turns it into a formal, repeatable structure that an AI agent can actually follow.
So what is it really? At its heart, the ReAct pattern forces an AI to cycle through a few key steps. First, it has to reason about what it needs to do. Then, it takes a specific action, like using a tool. And finally, it observes what happened as a result of that action. And that new piece of information? It gets fed right back into the loop for the next round of thinking. And this is the magic right here. It's so simple, but so powerful. Thought leads to an action, that action leads to an observation, and that observation feeds the next thought. It just keeps repeating that cycle over and over again until it's finally confident that it has the right answer. So let's break that down a little. The thought is basically the AI's internal monologue, where it plans out its next move. The action is where it actually does something in the real world, calls an API, looks something up in a database. And the observation is simply the result it gets back from that action. This little loop creates something called stateful reasoning, which is just a fancy way of saying the agent actually learns and builds up its knowledge with every single cycle.
Okay, so we know what ReAct is now, but let's talk about why it works so well. Why is this simple loop so incredibly good at fixing those huge problems of hallucination and unreliability that we talked about at the beginning?
Well, it really comes down to four massive benefits. First, you get grounded reasoning. The model is forced to check itself against reality using tools. It can't just trust its own memory. This immediately slashes hallucinations. Second, you get self-correction. If an action gives a weird result or just fails, the agent sees that and can adjust its plan. It learns from its mistakes in real time. And finally, and this is absolutely critical for any real-world use, you get interpretable intelligence. You have a perfect step-by-step audit trail of its entire decision-making process.
And this table here really just says it all. A direct answer from an LLM. It doesn't think, it doesn't act, and it can't use feedback. No way that's ready for production. Chain of thought? Okay, it thinks, but it can't act or use feedback to correct itself. Still risky. But ReAct, it checks all the boxes. It thinks, it acts, and it uses feedback. That's what makes it the only one on this list that's truly suitable for a production environment.
Okay, that's all the theory, but what does this actually look like in practice? How does a ReAct agent really solve a problem, step by step? Check out this example trace. The question is, what is the capital of the country with the highest population? Now, a basic LLM might just guess, but the ReAct agent doesn't. Its first thought is, okay, I need to figure out which country has the highest population. So it takes an action. It searches for it. It gets an observation back. China. Great. Now that it has a verified fact, its next thought is, okay, now I need the capital of China. It takes another action, another search, gets the observation, Beijing. And only then, after verifying each piece of the puzzle, does it give the final answer. See? Every single step is grounded in fact.
And this is where it gets really powerful in the real world. Think about customer support. You wouldn't want an AI just blindly issuing refunds, right? A ReAct agent wouldn't do that. It would first take an action to fetch the user's profile, then another action to check their order status, and only after observing that data would it decide whether to issue the refund. This is huge. It prevents costly mistakes and gives you a perfect audit trail for every single customer interaction. Or take it up a notch to something really high stakes, like government compliance. You could give an agent tools to check specific regulations and validate data against them. And because every single thought, action, and observation is logged, the final report isn't just a black box. It's completely transparent. It's legally defensible because you can point to the exact chain of logic and say, this is why the system made this decision. And all of this really points to a bigger picture. ReAct isn't just another clever technique or a library you import. It's really a fundamental shift in how we should think about building AI systems that are ready for the real world. There's this fantastic analogy for it that I think is just perfect. Stop thinking of the LLM as some kind of all-knowing magical oracle. Instead, think of it as a smart but very junior analyst. They can reason, they can form a plan, but you would never trust them to make a big decision without checking their facts first, right? You'd expect them to use tools to verify their assumptions and to show you their work. Well, that is exactly what the ReAct pattern forces the AI to do.
And this really gets to the ultimate point here. The goal with production AI isn't to make LLMs smarter in some abstract academic way. The goal is to make them reliable, to make them auditable, and to make them safe for the real world, especially for jobs where mistake has real, serious consequences. And ReAct is one of the most important patterns we have for getting there. So I'll just leave you with this one crucial question to think about for your own projects. Is your goal to build an AI that just seems smart? Or is it to build one that is truly, demonstrably, and verifiably reliable? Because the ReAct pattern makes a very, very strong case that the future of AI doesn't belong to the smartest, it belongs to the most reliable.